What's up? So I'm going to do this video a little bit backwards. So I'm going to go over the review for the test, which is on 2/20/18. That's next week, Tuesday. So you've got a whole 3-day weekend to study. You've got several IXLs you can study, and then this packet, which looks very similar to the actual test you'll be taking. Please remember, you have the weekend to study, 3 extra days, so there are no excuses for not getting an A. So the first thing I'm going to do on this problem is read it, and it says reflect over the y-axis. So I'm going to take this and I'm going to write the rule for y-axis, and it says what are the coordinates. I also have to write the coordinates for this. So a y-axis, I know that the x changes and the y stays the same. So the first thing I got to do is figure out what my coordinates are. So A is here at -3, 5. B is over here at 3, 3. And C is over here at -1, -2. All right, so the x's are going to change and the y's are going to stay the same. So A prime is now at 3, 5. B prime is at -3, 3. And C prime will be at 1, -2. And the rule again is -x, y. You can graph those if you'd like to see if you did it correctly. Remember, you're reflecting over the y-axis in this case, so that's this line here, and you'll see that becomes 1, -2. B is going to reflect back here, and A is going to reflect over here at 3, 5. All right, for the second question, it said you are going to translate 2 units down and 3 units to the right. Now, you are using the original shape. Okay, it says A, B, C. This one here is A prime, B prime, C prime. So you're going back to the original shape where A is at -3, 5, B is at 3, 3, and C is at -1, -2. And now you're going to translate it down 2 and 3 right. Okay, so then you got to draw it on the coordinate plane. So I'm going to subtract 2 from the y's, and I'm going to 3 to the right. I'm going to add 3 to the x. So, and we're calling it RST. So R is at 0, 3. S is at 6, 1. And T is at +2, -4. So 2 units down, that's negative, and 3 units to the right, that's positive. So R is going to be at 0, 3, 6, 1, and T is at 2, -4. And you should notice it's the same shape, it just went over 3, and down 2. Okay, what's the rule for this transformation? Well, you could say T, remember the x comes first, so it'd be +3, -2. Or you could say x +3, y -2. A couple different ways to write it. All right, moving right along. Change in size. Now, please remember that we learned one transformation that actually changes the size of a figure, and that was the one we learned yesterday. It's called a dilation. So if you're going to change the size of a figure, you are dilating it. So number 1 is dilation. Change in position. That means you're changing where it's located on the graph. The biggest one is a translation. But really, every single one of them changes the position of where it is on the graph. All right, change in orientation. That means that if it was standing upright, it's now upside down. So the two that would change orientation would be rotation and reflection. If you translate a figure that's standing up, it's still going to be standing up no matter what. And then the only one that is not equivalent or congruent in size, the pre-image and the image, would be a dilation, so it's all the other ones. So rotations are congruent, reflection, and translation. So some of them you can use more than once. Okay, so Sophia has a regular pentagon. She applies rotations to the shape around the center. Each rotation that Sophia performs carries the pentagon onto itself as shown. Okay, so what is the lowest degree of rotation that will carry the pentagon onto itself? Please remember, a rotation is a perfect circle, so it's 360 degrees to do a full rotation, okay? So if you're going to do one rotation, you need to count 1, 2, 3, 4, 5. In this particular case, there are 5 rotations that will carry this pentagon onto itself. So I'm going to take 360 divided by 5, and you get 72. So that means that if I'm going to turn this about itself from here to here, this is a 72-degree rotation. So what are other rotations that will also carry the pentagon onto itself that are less than 360? Well, if I did from angle 1 to here, that would add on another 72 degrees. So 72 plus 72 is 144. And if I went to this one, that would add on another 72 degrees, and that's 226. And then if I added on this one here, that would be 288. So those are the 3 rotations that will carry it onto itself. And remember, if it was 6, if it was a hexagon, you would divide by 6, heptagon 7, octagon 8, so on and so forth. All right, so this one says, which reflection will carry the hexagons onto themselves? Okay, so first we got to look at this drawing. And the first thing I'm going to test, I'm going to see, this is 1, 2, 3, this is 4 up here, and this is 1, 2, 3, 4 is right here. Okay, so it's not quite on the grid exactly correct if I were to fold it down along the x-axis. So now I'm going to check the y-axis. So this is 1, 2, 3, 4, 5, like 6 away. And over here it's 1, 2, 3, 4, 5, like 5.5 on both sides, 5.5 away. So they're actually equivalent when you look the distance that they are from the y-axis is equivalent. But the distance that they are from the x-axis is a little bit off, right? So this one, you would say that if I fold it along this line here, the two sides would match up evenly. So this would be a y-axis. It's very close to both, but that's the one that's going to work out. And if you did the y equals x line here, they're not going to fold on top of themselves. So the best answer is across the y-axis. All right. For number 5, it says, for each graph of a pre-image, perform the transformation indicated and label the transformed figure. So if I'm going to label the transformed figure, in this case, I'm going to do A prime, B prime is what I'm graphing. And it says across x equals 1. So again, I'm going to have to draw my line of reflection because it's not drawn for me yet. I'm going to go to x equals 1, that's here. And I have to draw a vertical line because if I draw a horizontal line, I end up on the x-axis, and that's not where I want to be. So now I've actually got to count how far away is B. 3, 1, 2, 3. So I'm going to go here, B prime. And then I do the same thing for A. It is 1, 2, 3, 4 away. 1, 2, 3, 4 away on this side. So I'm going to call that A prime, B prime, and that is my reflected image. All right, next for B, it says translate the image. This is going to be left, and this is down. So I'm literally, and it doesn't say that I have to write the coordinates, so I just have to do it on the graph. So I'm going to go left 2, down 3, and I have to label it F prime. left 2, down 3, and I have to label it D prime because it told me to. Left 2, down 3, B prime. That's where my new image exists. Rotate 90 degrees clockwise. So 90 degrees clockwise is to the right. So my coordinates are going to flip-flop, and the x goes negative. Okay, so this one I do probably have to write my coordinates down so that I can see where they end up. So this is at 3, 2. M is at 1, 2, 3, 4, 5, 2. N is at 5, negative 1. And P is at 3, negative 2. So when I rotate this clockwise, let me write P up here and N up here because I'm going to need this space here to rotate my. All right, so my new coordinates for L, so I'm going to write it L prime, are going to be at 2, negative 3. My new coordinates for M prime are at 2, negative 5. P prime is going to be at negative 2, negative 3, and N prime will be at negative 1, negative 5. So let's graph this and see if it comes out right. So 2, negative 3 is here, that's L prime. 2, negative 5 is here, N prime, and then we got negative 1, negative 5. Negative 1, negative 5, sorry. Negative 1, negative 5 here, that's N prime, and then negative 2, negative 3 is here. So it should look like this. And what you notice is that when you turn it, it's going to change its orientation. Okay, so that's a 90-degree clockwise. We rotated it to the right, and those are my new coordinates. In order to get full credit, though, you would have to also label all of my points. So I did L and M. This would be P prime, and there's N prime. All right, so the two quadrilaterals shown below are congruent with corresponding congruent parts marked in the diagram. So when you see angle A here, because it's got one tick mark, I can say that angle A is congruent to angle Q because they both have one tick mark. Okay. Now you want to describe what happened to carry this triangle, this kite or this quadrilateral onto this quadrilateral. So you're going from here to here, and you want to be very specific. You may use the coordinate grids to help you decide what happened. Okay. Go ahead and try some things out, pause the video, and we'll come back and see where you're at. When I approached this problem, the first thing I noticed is that A was laying on its side, and then it turned where it was standing up. So I know it's going to go through a 90-degree, and it's going to have to rotate, right? So it's going to be a 90-degree rotation this way. So A will be up at the top now, and then C will be down at the bottom. Because it was laying down, so now it's going to be standing flat. So that we call that a 90-degree. It's going to this clockwise direction, so clockwise. So that means that it's going to be, counterclockwise. So that means the rule is going to be negative y, comma, x. Okay, and that's going to put my new coordinates at 0, negative 5, B prime is at negative 5, negative 9, and I'm going to pause this so you can come back and see. I got to the red, I noticed I had to translate up 7, and then I noticed it was an exact flip or a reflection on the x equals 2, 5. All right, if you have questions on that, let me know. And then you're going to quickly see the answers here. You might want to pause the video and check to make sure that you got those relationships correct. Okay, each of these questions are very similar, if not the same, as the questions you'll see on the test. So make sure you are studying everything very clearly.